Now we move into solving trigonometric equations. And we're going to use that using identities. Trigonometric equations are nothing fancy. You've dealt all along with equations and solving them for x and y, x squared. Now we're going to fold cosine and sine and tangent and other things into the mix, and makes things a little more complicated, but you also get some more tools to work with. Some of these tools are the Pythagorean Identities, your book calls them, and one form of it sine squared of x plus cosine squared of x equals 1. So this means in your equation, if you see cosine squared of x, you can replace it with 1 minus sine squared of x. And often this will let you simplify an equation. We talked about this a little bit. These are called Pythagorean identities and there's two other forms of them. I'll show you them in a second. But they come from the Pythagorean theorem. If this is side A, B, and C, then a squared plus b squared, this is a right triangle. Can't be just any old triangle. Equals c squared. There is a more general form, but we won't deal with that. Now, notice we call this the opposite side. Opposite side squared plus adjacent side squared equals hypotenuse squared. See where I'm going with this? Let's divide everything by h squared. We'll divide this side by h squared, sort of h squared sort of factors through. And now we have opposite squared over hypotenuse squared, which is sine squared x, if this is the angle x. Adjacent over hypotenuse, cosine squared x equals 1. So really this is just the Pythagorean theorem in different clothes. And this identity has two other forms too. This is one we use a lot. It has two other forms. What if, remember that tangent equals sine over cosine. This is another identity. And cotangent equals cosine over sine. These are sort of your general trigonometric identities. The other one is secant equals 1 over cosine. Cosecant equals 1 over sine. You probably remember these. And cotangent can be also thought of as 1 over tangent. Alright, so these things are sort of the new building blocks we're going to be playing with and building equations with these. So tangent equals sine over cosine. What if we take this equation and we divide everything by cosine? Basically we're dividing both sides by cosine squared of x. So we could do a whole line and then say cosine squared of x and then break it into two. I'm going to do it in one step. Over cosine squared of x. So what happens here, sine squared x over cosine squared x, that's tangent squared x. Cosine squared over cosine x is 1. And 1 over cosine squared x is going to be secant squared x. Similarly, we could divide the whole thing by sine, and then we get 1 plus cotangent squared x equals 1 over sine cosecant x. So this is the same equation, and you can see it's the same equation here, just in different forms. So the different forms will be useful to us at different times. For example, say you had this equation, sine of x minus sine of x cosine squared of x. And you wanted to simplify this equation. It's not very nice looking. You can notice you can factor out a sine of x. You get 1 minus cosine squared of x. And you can say, oh, and 1 minus cosine squared of x. From this identity up here, just subtracting cosine squared of x from both sides, says that's equal to sine squared x. So this simplifies to sine of x times sine squared x. And this equals sine cubed x. Notice we are sticking the square there. We have to be very careful not to mix up our sine to the minus 1 of x, which is the inverse sine or arc sine. That does not mean 1 over sine of x. We want to do that, 1 over sine of x. We should just write 1 over sine of x or do it like that. Okay? So this identity is very helpful. These are the other pieces of the puzzle that you put sine, cosine, and tangent together. I'll give you a hint. It's often easier just to change everything to sine and cosine and see if things disappear. And then switch sine squareds to 1 minus cosine squared. See if it makes things easier. Maybe try and switch to one kind. The other helpful things are looking at, I'm going to draw your perennial cosine sine graph here and cosine. We talked about earlier even and odd functions. Here's cosine. If you do minus x, it's going to be the same thing as x. So this is an even function. So that means cosine of minus x equals cosine of x. Okay, it's an even function, meaning wherever you put in x minus x, it's the same thing, and you get an x out. So we can often simplify cosine of minus x and write it as cosine of x. Sine does not mirror itself through here. It flips over. Where you have a 1, you have a minus 1. Where you have a 1 here, you have a minus 1 here. So sine of minus x equals minus sine of x. This is an odd function. Odd, even. Alright, these are other identities that are helpful. Tangent. I will draw a little bit of tangent. So 0 goes up to infinity. There's other ones of these out here. Is that going to be even or odd? Well, if you put a mirror up and you get the same thing, then it's even. But here you don't. You get a flipped over thing. So this is also odd. So that means tangent of minus x equals minus tangent of x. Alright, so where you put in and get a point, I don't know, 3.5, if you go the other direction, you get minus 3.5. So it switches sides there. Okay? And similarly, cosecant goes as sine does, so you rarely use these. Cosecant of minus x. Behave cosecant, think of as 1 over sine. So it has the same behavior in terms of being an odd function. Secant goes as cosine. So that means there's no minus sign here. That equals secant of x. Alright, these are sort of the formulas for dealing with the negative signs in here. Cotangent goes as tangent, so just to be complete, cotangent of minus x equals minus tangent of x. So they are all odd functions except for cosine and cosine's partner in crime, secant. These are your two odd functions. Oops, sorry. No, those are even functions. The other ones are odd. So if you can take the minus sign out, but it comes out front. Here, this just I don't know why I wrote this on here. Cosine of minus x equals cosine of x. Okay, so that's dealing with those. Combine that with the sine squared x plus cosine squared of x equals 1. Combine that with that and its two other forms, and you have a bunch of tools for solving trig equations. I'll do a really quick, simple one. Let's see, what did the book have? Cosine x tangent of x. What does that equal? 2. Again, these don't have to be x. Well, we can write out tangent as sine over cosine. So we have cosine x in the top, cosine x in the bottom. They cancel out. So this whole thing is just equal to sine of x. You will see some big ugly equations with stacks of things. That's pretty neat how they all boil down. They often boil down to a simple expression. Alright, we'll try some problems with that. And you'll be well on your way to working with trigonometric equations.